connected to your valve position as is required. Then we have electric motor actuators. Now instead of solenoid, what we have is electric stepper motors which control the movement of the stem valve. Now the advantage of having a stepper motor is stepper motor can be controlled in small steps, very precise small steps. It can, for one 360-degree revolution, it could have maybe 20 steps, 40 steps, 80 steps. So for one revolution, if it goes through 80 steps, you can see how precise the control would be. So whenever you have a stepper motor, you would also have a rack and pinion arrangement to convert the motor rotation into lateral movement, into linear movement.
Do you stop this kind of electric motor actuators in a specific valve, or you can install it in any valve at all?
Depends on your, see, these kind of valves are little expensive. Stepper motor valve is a little expensive because stepper motors are expensive. So it depends on your requirement. If you require a precise, if you are doing your controlling using a microprocessor or a PLC, and if you use a stepper, you get a very good command over it. So you can maybe for a the amount of control that you get in opening the valve would be phenomenal. Because let's say for a 360-degree movement, I can get 40 turns, 40 steps. So I have a control over less than 1 degree of movement of my stepper motor.
So a servo is like another option for that application, because I work with servo valves as well. So
you work with what valves?
Servo valves.
Solenoid valves, okay.
Servo valves.
Can you just write it down?
Yes.
Where did you write down? Can you write down your Skype? Not any of them.
I'm sleeping right now.
I can see, you can see my computer, I can't see your computer screen, sorry. Servo valves, yeah. So servo, okay. So yeah, even that is kind of a electric motor actuator. The advantages of servo valves is that they can generate very high wattage. So if you are trying to use your valve in a high pressure environment, yes, servo valves would then make sense. So it again depends on your requirement. Now, if your operations that you're doing do not have pressure, if you don't have the pneumatic pressure available, then you would have to go either for your solenoid valve, servo valve, or stepper motor valve. So one of the options has to be provided. Then you look at your costing. Solenoid valves would be cheaper as compared to electric motor actuators, because solenoid they don't generate the same amount of power. Same amount of power is the right word.
Probably the precise, you have less precise. It's not too precise like the other one. Right?
Yes, they are not precise and they don't have the same amount of power. Servo valves can be used in high pressure areas because they have high power. They are normally high power motors.
Yes.
Okay. And where you require precision, you could go for stepper motor kind of an application. Then we have is rotary actuators. In rotary actuators, we have a rack pinion, Scotch yoke, and a vane actuator. So look at the figure shown on the right side. You have a double acting dual rack and pinion actuator. So in this actuator, you have an inlet port and an outlet port. So the first diagram shows you the inlet port as port 2. When the air goes inside from the port 2, what happens is your pistons move inside and your pinion rotates. So if you have a rotatory valve connected to your rack and pinion actuator, it would open up. Right? So your valve would be connected here on this pinion. If you change your port from 2 to 1, your rack, then your inlet port gets connected here. So your air now is on the inside of the pistons, in the inside area, and your rack moves back, rotating the pinion in anti-clockwise direction. So by changing the ports, you control the movement of your pinion, either to clockwise or anti-clockwise. If my inlet port is 2, I have a clockwise movement of my rack. If my inlet port is 1, you have the anti-clockwise movement of your rack. Right? So this is a double acting dual rack and pinion actuator. Now this generates a lot of power because it is a double rack arrangement. There is a single rack arrangement, but then the power generated is lesser than the double rack arrangement. How does my single rack arrangement works? Again by the same method. You have port 1, my rack moves outwards. When you have port 2 as inlet port, my rack moves inward. Accordingly, my pinion rotates clockwise or anti-clockwise direction. However, this actuator operates similar to dual rack but does not provide as much power. Another design for this rack is a spring return dual rack and pinion actuator. Now in this case I do not require to change my inlet port because the force for retracting the pinion, the racks, and moving the pinion in anti-clockwise direction is provided by the spring. So when air enters in the port 1, my rack moves outwards, compressing the springs, and my pinion moves in an anti-clockwise direction. Moment my air is stopped, the signal falls, the springs force the movement of rack inside. So the rack now moves inside, which causes my pinion to move in a clockwise direction. Then you have something called a Scotch yoke actuator. So what this does is, it converts the piston's linear motion into the valve's required rotary position. So whenever you have a linear motion actuator, but the valve is a rotary motion, you use the Scotch yoke actuator. Scotch yoke actuator. So what is happening here is, if you look at figure 12, it shows a double acting Scotch yoke actuator. Again, I would have a pneumatic signal being provided at one port, and then there is the other port. So two ports are supplied in two position operation. When you reposition the operator, one side of the piston must be pressurized at the same time as the opposite side is vented. So if the inlet port is this port, my Scotch yoke rotates in an anti-clockwise direction. When I change my port to this port, inlet port changes. In that case, my scotch yoke rotates in a clockwise direction. So that is why it is called double acting. Whenever you have two ports, it is a double acting. And how do I switch the port? I use a solenoid valve to switch the air signals. We were discussing solenoid valves earlier. So solenoid valve is used to switch the port. So inlet port keeps changing. With the addition of a spring on the left side of the cylinder, I can make this as a single acting scotch yoke actuator. So spring gives me a fail-safe design also. It also provides me a fail-safe design. How does it provide me a fail-safe design? Hassan?
Spring.
Yeah. Now this is a pneumatic signal. In case there is an air failure, what would it do? My spring will expand and provide me I know I have a fail-safe available, right? It will provide me a fail-safe operation. It could be fails to close or fail to open, that does not matter. But fail-safe is available because I have added a spring. So spring provides me a fail-safe. Same is the case in this rack and pinion actuator. When I added the spring, this provided me a fail-safe option. That if the air fails, my spring would bring it to a predetermined position. I know my pinion would move in the clockwise direction, and it would stay there. So a fail-safe operation is available. Okay? So addition of spring to any actuator design provides you a fail-safe option. Then you have a vane actuator. You can just read about it. There's nothing major about this that can be asked. I think we can take up the rest of them tomorrow. Look at your question sheets and look at in your questions. You have to look at block C. Vitello, can you see block C? After block B, there will be block C.
Yes, I know understand.
Yes, so maybe today we can have a look. Today evening we can just finish this block C.
Okay.
Okay?
So I think we are done, right?
No, we're not done. We still have 3 days to go.
I don't like to stay with you till the midnight. Trust me.
No, I'm sorry. I have my girlfriend, so I don't want to stay with you at midnight. I'd rather go with my girlfriend, sorry.
That's a very nice answer. Okay, my friend, so have a good night. Take care.
Take care. Bye. Good night.